Hi, in this video, I will be going over problem number 15 of the antiderivative section, chapter 4, section 9. Find the most general antiderivative of the function. Check your answer by differentiation. Use C for the constant of the antiderivative. G of t equal to 4 plus t square over square root of t. Because it's an introductory section on antiderivative, we have done only very few formulas, one of which is antiderivative of a function like x to the power n, which is x to the power n plus 1 over n plus 1, where n is not equal to negative 1. Then we will be introducing the symbol like this in chapter 5. Integral x to the n dx is x to the n plus 1 over n plus 1, where n is not equal to negative 1. So when n equal to negative 1 though, it is integral of 1 over x, which is ln of absolute x. Okay. But as general antiderivative, you need to remember to add the constant c. So we can divide each term individually by square root of t, or you can take t, which is actually equal to t to the power 1 half, to the numerator, and that will become t to the negative 1 half. Now you expand or distribute t to the negative 1 half. So it is 4t to the negative 1 half plus t times t to the negative 1 half plus t squared times t to the negative 1 half. So it is 4 times t to the negative 1 half plus t to the 1 half plus t to the exponent 3 halves. Now the general antiderivative, the most general antiderivative is, I'm going to call it uppercase G, just 4t to the negative 1 half plus 1. So it is exponent plus 1 over exponent plus 1. So negative 1 half plus 1 plus t to the 1 half plus 1 over 1 half plus 1 plus t to the 3 halves plus 1 over 3 halves plus 1 plus c. So it is 4, then t to the 1 half here, that will be square root of t divided by 1 half plus t to the 3 halves divided by 3 halves plus 3 to the 5 halves divided by 5 halves plus c. So you can write this as 8, the 2 gets multiplied, right? So 8 times square root of t plus 2 over 3, so this gets flipped, t to the power 3 halves, and 5 by 2 gets flipped, so 2 over 5, t to the 5 halves plus c. Don't forget to add the c because it is general antiderivative. The second part of the problem is to check, meaning if we have to differentiate the antiderivative and see whether we get the original function back. So the question is uppercase G prime t equal to G of t? So this is the part you want to check. So that means our antiderivative is correct. So let's do the derivative of G, uppercase G. So now it is 8. Derivative of square root of t, so it's 1 over 2 square root of t plus 2/3 t to the power 3 halves, so it is 3 halves t to the power 1 half. You are taking the derivative, so it is n x to the n minus 1, exponent times variable to the exponent minus 1. That is the derivative rule. So 2/5 and 5 over 2 times t to the exponent 5 halves minus 1, which will be a 3 halves. derivative of a constant is 0. So if you reduce this, you get 4 over square root of t, which can be written as t to the negative 1 half, plus 3 and 3 cancel out, 2 and 2 cancel out, square root of t, or t to the 1 half. You can write that as, leave it as t to the 1 half. These two cancel out, plus t to the 3 halves, which is exactly lowercase g of t. So uppercase g prime t equal to lowercase g of t, which is the verification that uppercase g of t is actually the antiderivative. So antiderivative of lowercase g of t is uppercase g of t, which is whatever we have written here, right? Hope this video helps.